Welcome to Data Sourcing. I'm Barton Poulson, and in this course, we're going to talk about data opus, or that's Latin for data needed. The idea here is that no data science, and that is a sad thing. So instead of leaving it at that, we're going to use this course to talk about methods for measuring and evaluating data, and methods for accessing existing data, and even methods for creating new custom data. Take those together, and it's a happy situation. At the same time, we'll do all of this still at an accessible, conceptual, and non-technical level because the technical hands-on stuff will happen in later other courses. But for now, let's talk data. For data sourcing, the first thing we want to talk about is measurement. And within that category, we're going to talk about metrics. The idea here is that you actually need to know what your target is if you want to have a chance to hit it. There's a few particular reasons for this. First off, data science is action-oriented. The goal is to do something as opposed to simply understand something, which I say as an academic practitioner. Also, your goal needs to be explicit, and that's important because the goals can guide your effort. So you want to say exactly what you're trying to accomplish so you know when you get there. Also, goals exist for the benefit of the client because they can prevent frustration. They know what you're working on. They know what you have to do to get there. And finally, the goals and the metrics exist for the benefit of the analyst because they help you use your time well. You know when you're done, you know when you can move ahead with something, and that makes everything a little more efficient and a little more productive. Now, when we talk about this, the first thing you want to do is try to define success in your particular project or domain. Depending on where you are in commerce, that can include things like sales or click-through rates or new customers. In education, it can include scores on tests. It can include graduation rates or retention. In government, it can include things like housing and jobs. In research, it can include the ability to serve the people that you're trying to better understand. So whatever domain you're in, there will be different standards for success, and you're going to need to know what applies in your domain. Next are specific metrics or ways of measuring. Now, again, there are a few different categories here. There are business metrics. There are key performance indicators or KPIs. There are SMART goals, that's an acronym. And there's also the issue of having multiple goals. I'll talk about each of those for just a second now. First off, let's talk about business metrics. If you're in the commercial world, there are some common ways of measuring success. A very obvious one is sales revenue. Are you making more money? Are you moving the merchandise? Are you getting sales? Also, there's the issue of leads generated, new customers or new potential customers, because that then in turn is associated with future sales. There's also the issue of customer value or lifetime customer value. So you may have a small number of customers, but they all have a lot of revenue, and you can use that to really predict the overall profitability of your current system. And then there's churn rate, which has to do with losing and gaining new customers and having a lot of turnover. So any of these are potential ways of defining success and measuring it. These are potential metrics. There are others, but these are some really common ones. Now, I mentioned earlier something called a key performance indicator or KPI. KPIs come from David Parmenter, and he's got a few ways of describing them. He says a key performance indicator for business, number one, should be non-financial. So not just the bottom line, but something else that might be associated with it or that measures the overall productivity of the association. They should be timely, for instance, weekly, daily, or even constantly gathered information. They should have a CEO focus. So the senior management team are the ones who generally make the decisions that affect how the organization acts on the KPIs. They should be simple. So everybody in the organization, everybody knows what they are and knows what to do about them. They should be team-based, so teams can take joint responsibility for meeting each one of the KPIs. They should have significant impact. What that really means is they should affect more than one important outcome. So you can do profitability and market reach, or improved manufacturing time and fewer defects. And finally, an ideal KPI has a limited dark side. That means there's fewer possibilities for reinforcing the wrong behaviors and rewarding people for sort of exploiting the system. Next, there are SMART goals, where SMART stands for specific, measurable, assignable to a particular person, realistic, meaning you can actually do it with the resources you have at hand, and time bound, so you know when it can get done. So whenever you form a goal, you should try to assess it on each of these criteria. And that's a way of saying that this is a good goal to be used as a metric for the success of our organization. Now, the trick, however, is when you have multiple goals, multiple possible endpoints. And the reason that's difficult is because, well, it's easy to focus on one goal if you're just trying to maximize revenue, or if you're just trying to maximize, graduation rate. There's a lot of things you can do. It becomes more difficult when you have to focus on many things simultaneously, especially because some of these goals may conflict. The things that you do to maximize one may impair the other. And so when that happens, you actually need to start engaging in a deliberate process of optimization. You need to optimize. And there are ways that you can do this. If you have enough data, you can do a mathematical optimization to find the ideal balance of efforts to pursue one goal and the other goal at the same time. Now, this is a very general summary, and let me finish with this. In sum, metrics or methods for measuring can help awareness of how well your organization is functioning and how well you're reaching your goals. There are many different methods available for defining success and measuring progress towards those things. The trick, however, comes when you have to balance efforts to reach multiple goals simultaneously, which can bring in the need for things like optimization. When talking about data sourcing and measurement, one very important issue has to do with the accuracy of your measurements. The idea here is that you don't want to have to throw away all your ideas. You don't want to waste effort. One way of doing this in a very quantitative fashion is to make a classification table. So what that looks like is this. You talk about, for instance, positive results, negative results. And in fact, let's start by looking at the top here. The middle two columns here talk about whether an event is present, whether your house is on fire, whether a sale occurs, whether you've got a tax evader, whatever. So that's whether a particular thing is actually happening or not. On the left here is whether the test or the indicator suggests that a thing is or is not happening. And then you have these combinations of true positives, where the test says it's happening and it really is, and false positive, where the test says it's happening but it's not. And then below that, true negatives, where the test says it isn't happening and that's correct. And then false negatives, where the test says there's nothing going on, but there is in fact the event occurring. And then you start to get the column totals, the total number of events present or absent, and the row totals that talk about the test results. Now, from this table, what you get is 4 kinds of accuracy, or really 4 different ways of quantifying accuracy using different standards. And they go by these names: sensitivity, specificity, positive predictive value, and negative predictive value. I'll show you very briefly how each of them works. Sensitivity can be expressed this way. If there's a fire, does the alarm ring? You want that to happen. And so that's a matter of looking at the true positives and dividing that by the total number of alarms. So the test positive means there's an alarm, and the event present means there's a fire. You want always to have an alarm when there's a fire. Specificity, on the other hand, is sort of the flip side of this. If there isn't a fire, does the alarm stay quiet? This is where you're looking at the ratio of true negatives to total absent events, where there's no fire and the alarm's not ringing, and that's what you want. Now, those are looking at columns. You can also go sideways across rows. So the first one there is positive predictive value, often just abbreviated as PPV. And we flip around the order a little bit. This one says, if the alarm rings, was there a fire? So now you're looking at the true positives and dividing it by the total number of positives. Total number of positives is any time the alarm rings. True positives is because there was a fire. And negative predictive value, or NPV, says if the alarm doesn't ring, does that in fact mean that there is no fire? Well, here you're looking at true negatives and dividing it by total negatives the time that it doesn't ring. And again, you want to maximize that so the true negatives account for all of the negatives, the same way you want the true positives to account for all of the positives, and so on. Now, you can put numbers on all of these going from 0% to 100%, and the idea is to maximize each one as much as you can. So in sum, from these tables, we get 4 kinds of accuracy, and there's a different focus for each one, but the same overall goal. You want to identify the true positives and true negatives and avoid the false positives and false negatives. And this is one way of putting numbers on, an index really, on the accuracy of your measurement. Now, data sourcing may seem like a very quantitative topic, especially when we're talking about measurement, but I want to measure one important thing here, and that is the social context of measurement. The idea here really is that people are people, and they all have their own goals and they're going their own ways. And we all have our own thoughts and feelings that don't always coincide with each other. And this can affect measurement. And so, for instance, when you're trying to define your goals and you're trying to maximize them, you want to look at things like, for instance, the business model. An organization's business model, the way they conduct their business, the way they make their money, is tied to its identity and its reason to be. And if you make a recommendation that's contrary to their business model, that can actually be perceived as a threat to their core identity, and people tend to get freaked out in that situation. Also, restrictions. So for instance, there may be laws, policies, and common practices, both organizationally and culturally, that may limit the ways that goals can be met. Now, most of these make a lot of sense. So the idea is you can't just do anything you want. You need to have these constraints. And when you make your recommendations, maybe you'll work creatively in them as long as you're still behaving legally and ethically. But you do need to be aware of these constraints. Next is the environment. And the idea here is that competition occurs both between organizations. That company here is trying to reach a goal, but they're competing with company B over there. But probably even more significantly, there is competition within the organization. This is really a recognition of office politics, and that when you as a consultant make a recommendation based on your analysis, you need to understand you're kind of dropping a little football into the office, and things are going to further one person's career, maybe to the detriment of another. And in order for your recommendations to have the maximum effectiveness, they need to play out well in the office. That's something that you need to be aware of as you're making your recommendations. Finally, there's the issue of manipulation. And a sad truism about people is that any reward system at all, will be exploited, and people will generally game the system. This happens especially when you have a strong cutoff. You need to get at least 80% or you get fired. And people will do anything to make their numbers appear to be 80%. This happens an awful lot when you look at executive compensation systems. It looks a lot when you have very high stakes school testing. It happens in an enormous number of situations. And so you need to be aware of the risk of exploitation and gaming. Now, don't think then that all is lost. Don't give up. You can still do really wonderful assessment. You can get good metrics. Just be aware of these particular issues and be sensitive to them as you both conduct your research and as you make your recommendations. So, in sum, social factors affect goals, and they affect the way that you meet those goals. There are limits and consequences both on how you reach the goals and how really what the goal should be. And that when you're making advice on how to reach those goals, please be sensitive to how things play out with metrics and how people will adapt their behavior to meet the goals. That way, you can make something that's more likely to be implemented the way you meant and more likely to predict accurately what can happen with your goals. When it comes to data sourcing, obviously the most important thing is to get data, but the easiest way to do that, at least in theory, is to use existing data. Think of it as going to the bookshelf and getting the data that you have right there at hand. Now, there's a few different ways to do this. You can get in-house data, you can get open data, and you can get third-party data. Another nice way to think of that is proprietary, public, and purchased data, the 3 Ps I've heard it called. Let's talk about each of these a little bit more. So in-house data, that's stuff that's already in your organization. What's nice about that is it can be really fast and easy. It's right there. And the format may be appropriate for the kind of software and the computer that you're using. If you're fortunate, there's good documentation, although sometimes when it's in-house, people just kind of throw it together. So you have to watch out for that. And there's the issue of quality control. Now, this is true with any kind of data, but you need to pay attention with in-house because you don't know the circumstances necessarily under which people gathered the data and how much attention they were paying to something. There's also an issue of restrictions. There may be some data that while it's in-house, you may not be allowed to use, or you may not be able to publish the results or share the results with other people. So these are things that you need to think about when you're going to use in-house data in terms of how can you use it to facilitate your data science projects. Specifically, there are a few pros and cons. In-house data, potentially quick, easy, free. Hopefully it's standardized. Maybe even the original team that conducted this study is still there. And you might have identifiers in the data which make it easier for you to do an individual level analysis. On the con side, however, the in-house data simply may not exist. Maybe it's just not there. Or the documentation may be inadequate. And of course, the quality may be uncertain. It's always true, but maybe something you have to pay more attention to when you're using in-house data. Now, another choice is open data, like going to the library and getting something. This is prepared data that's freely available. It consists of things like government data and corporate data and scientific data from a number of sources. Let me show you some of my favorite open data sources, just so you know where they are and that they exist. Probably the best one is data.gov here in the US. That is it says right here, the home of the US government's open data. Or you may have a state level one. For instance, I'm in Utah and we have data.utah.gov, also a great source of more regional information. If you're in Europe, you have open-data.europa.eu, the European Union Open Data Portal. And then there are major nonprofit organizations. So the UN has unicef.org/statistics for their statistical and monitoring data. The World Health Organization has the Global Health Observatory at who.int/GHO. And then there are private organizations that work in the public interest, such as the Pew Research Center, which shares a lot of its data sets, and the New York Times, which makes it possible to use APIs to access a huge amount of the data of things they've published over a huge time span. And then two of the mother loads, there's Google, which at google.com has public data, which is a wonderful thing. And then Amazon at aws.amazon.com datasets has gargantuan datasets. So if you needed a dataset that was like 5 terabytes in size, this is the place that you would go to get it. Now, there's some pros and cons to using this kind of open data. First is that you can get very valuable datasets that maybe cost millions of dollars to gather and to process. And you can get a very wide range of topics and times and groups of people and so on. And often the data is very well formatted and well documented. There are, however, a few cons. Sometimes there's biased samples. Say, for instance, you only get people who have internet access, and that can mean, not everybody. Sometimes the meaning of the data is not clear, or it may not mean exactly what you want it to. A potential problem is that sometimes you may need to share your analyses. And if you're doing proprietary research, well, it's going to have to be open research instead. And so that can create a crimp with some of your clients. And then finally, there are issues with privacy and confidentiality. And in public data, that usually means that the identifiers are not there and you're going to have to work at a larger aggregate level of measurement. Another option is to use data from a third party. These go by the name Data as a Service, or DAS. You can also call them data brokers. And the thing about data brokers is they can give you an enormous amount of data on many different topics. Plus, they can save you some time and effort by actually doing some of the processing for you. And that can include things like consumer behaviors and preferences. They can get contact information. They can do marketing, identity, and finances. There's a lot of things. There's a number of data brokers around. Here's a few of them. Axiom is probably the biggest one in terms of marketing data. There's also Nielsen, which provides data primarily for media consumption. And there's another organization, DataSift. That's a smaller, newer one. And there's a pretty wide range of choices, but these are some of the big ones. Now, the thing about using data brokers, there's some pros and there's some cons. The pros are, first, that it can save you a lot of time and effort. It can also give you individual level data, which can be hard to get from open data. Open data is usually at the community level. They can give you information about specific consumers. They can even give you summaries and inferences about things like credit scores and marital status, possibly even whether a person gambles or smokes. Now, the con is this. Number one, it can be really expensive. I mean, this is a huge service. It provides a lot of benefit and is priced accordingly. Also, you still need to validate it. You still need to double check that it means what you think it means and that it works in with what you want. And probably a real sticking point here is the use of third-party data is distasteful to many people. And so you have to be aware of that as you're making your choices. So in sum, as far as data sourcing existing data goes, obviously data science needs data. And there's the 3 P's of data sources: proprietary and public and purchased. But no matter what source you use, you need to pay attention to quality and to the meaning and the usability of the data to help you along in your own projects. When it comes to data sourcing, a really good way of getting data is to use what are called APIs. Now, I like to think of these as the digital version of Prufrock's Mermaids, if you're familiar with the love song of J. Alfred Prufrock by T.S. Eliot. He says, "I have heard the mermaids singing each to each." That's T.S. Eliot. And I like to adapt that to say, APIs have heard apps singing each to each, and that's by me. Now, more specifically, when we talk about an API, what we're talking about is something called an application programming interface. And this is something that allows programs to talk to each other. Its most important use in terms of data science is it allows you to get web data. It allows your program to directly go to the web on its own, grab the data, bring it back in, almost as though it were local data. And that's a really wonderful thing. Now, the most common version of APIs for data science are called REST APIs. That stands for Representational State Transfer. That's the software architectural style of the World Wide Web. And it allows you to access data on web pages via HTTP. That's the Hypertext Transfer Protocol that, runs the web as we know it. And when you download the data, you usually get it in JSON format. That stands for JavaScript Object Notation. The nice thing about that is that's human readable, but it's even better for machines. Then you can take that information and you can send it directly to other programs. And the nice thing about REST APIs is that they're what's called language agnostic, meaning any programming language can call a REST API, can get data from the web, and can do whatever it needs to with it. Now, there are a few kinds of APIs that are really common. The first is what are called social APIs. These are ways of interfacing with social networks. So for instance, the most common is Facebook. There's also Twitter. Google Talk has been a big one, and Foursquare as well. And then SoundCloud. These are on lists of the most popular ones. And then there are also what are called visual APIs, which are for getting visual data. So for instance, Google Maps is the most common. But YouTube, something that accesses YouTube on a particular website, or AccuWeather, which is for getting weather information, Pinterest for photos, and Flickr for photos as well. So these are some really common APIs, and you can program your computer to pull in data from any of these services and sites and integrate it into your own website or here into your own data analysis. Now, there's a few different ways you can do this. You can program it in R, the statistical programming language. You can do it in Python. Also, you can even do it in the very basic Bash command line interface. And there's a ton of other applications. Basically, anything can access an API one way or another. Now, I'd like to show you how this works in R. So I'm going to open up a script in RStudio, and then I'm going to use it to get some very basic information from a web page. Let me go to RStudio and show you how this works. I've opened up a script in RStudio that allows me to do some data sourcing here. Now, I'm just going to use a package called JSON-Lite. I'm going to load that one up. And then I'm going to go to a couple of websites. I'm going to be getting historical data from Formula One car races, and I'm going to be getting it from airgas.com. Now, if we go to this page right here, I can just go straight to my browser right now. And this is what it looks like. It gives you the API documentation. So what you're doing for an API is you're just entering a web address, and in that web address, it includes the information that you want. I'll go back to R here for a second. And if I want to get information about 1957 races in JSON format, I go to this address, and I can skip over to that for a second. And what you see is it's kind of a big long mess here, but it is all labeled and it's clear to the computer what's going on here. I'll go back to R. And so what I'm going to do is I'm going to save that URL into an object here in R. And then I'm going to use the command from JSON to read that URL and save it into R, and which it is now done. And I'm going to zoom in on that so you can see what's happened. I've got this sort of mess of text. This is actually a list object in R. And then I'm going to get just the structure of that object. So I'm going to do this one right here. And you can see that it's a list, and it gives you the names of all the variables within each one of the lists. And what I'm going to do is I'm going to convert that list to a data frame I went through the list and found exactly where the information I wanted was located. You have to use this big, long statement here. That'll give me the names of the drivers. Let me zoom in on that again. There they are. And then I'm going to get just the column names for that bit of the data frame. And so what I have here is 6 different variables. And then what I'm going to do is I'm going to pick just the first 5 cases, and I'm going to select some variables and put them in a different order. And when I do that, this is what I get. I'll zoom in on that again. And the first 5 people listed in this data set that I pulled in from 1957 are Juan Fangio, makes sense, one of the greatest drivers ever, and other people who competed in that year. And so what I've done is by using this API call in R, it's a very simple thing to do, I was able to pull data off that web page in a structured format and do a very simple analysis with it. And let's sum up what we've learned from all of this. First off, APIs make it really easy to work with web data. They structure it, they call it for you, and then they feed it straight into the programs for you to analyze. And they're one of the best ways of getting data and getting started in data science. When you're looking for data, another great way of getting data is through scraping. And what that means is pulling information from web pages. I like to think of it as when data is hiding in the open. It's there, you can see it, but there's not an easy, immediate way to get that data. Now, when you're dealing with scraping, you can get data in several different formats. You can get HTML text from web pages. You can get HTML tables, the rows and columns that appear on web pages. You can scrape data from PDFs, and you can scrape data from all sorts of media like images and video and audio. Now, we'll make one very important qualification before we say anything else. Pay attention to copyright and privacy. Just because something is on the web doesn't mean you're allowed to pull it out. Information gets copyrighted. And so when I use examples here, I make sure that this is stuff that's publicly available, and you should do the same when you're doing your own analyses. Now, if you want to scrape data, there's a couple of ways to do it. Number one is to use apps that are developed for this. So for instance, import.io is one of my favorites. It's both a web page, that's its address, and it's a downloadable app. There's also Scraper Wiki. There's an application called Tabula, and you can even do scraping in Google Sheets, which I'll demonstrate in a second, and Excel. Or if you don't want to use an app, or if you want to do something that apps don't really let you do, you can code your scraper. You can do it directly in R, or Python, or Bash, or even Java or PHP. Now, what you're going to do is you're going to be looking for information on the web page. If you're looking for HTML text, what you're going to do is you're going to pull structured text from web pages, similar to how a reader view works in a browser. it uses HTML tags on the web page to identify what's the important information. So that's things like body and H1 for header 1 and P for paragraph in the angled brackets. You can also get information from HTML tables, although this is a physical table of rows and columns I'm showing you. This also uses HTML table tags. That's like table and TR for table row and TD for table data. That's a cell. The trick is when you're doing this, you need the table number, and sometimes you just have to find that through trial and error. Let me give you an example of how this works. Let's take a look at this Wikipedia page on the Iron Chef America competition. I'm going to go to the web right now and show you that one. So here we are in Wikipedia, Iron Chef America. And if you scroll down a little bit, you see we got a whole bunch of text here, and we got our table of contents. And then we come down here, we have a table that lists the winners, the statistics for the winners. And let's say we want to pull that from this web page into another program for us to analyze. Well, there's an extremely easy way to do this with Google Sheets. All we need to do is open up a Google Sheet, and in cell A1 of that Google Sheet, we paste in this formula. It's import HTML, then you give the web page, then you say that you're importing a table. You have to put that stuff in quotes, and the index number for the table. I had to poke around a little bit to figure out that this one was table number 2. So let me go to Google Sheets and show you how this works. Here I have a Google Sheet, and right now it's got nothing in it, but watch this. If I come here to this cell and I simply paste in that information, all this stuff just sort of magically propagates into the sheet, makes it extremely easy to deal with. And now I can, for instance, save this as a CSV file, put it in another program, lots of options. And so this is one way that I'm scraping the data from a web page because I didn't use an API, but I just use a very simple one-line command in Google Sheets to get the information. Now that was an HTML table. You can also scrape data from PDFs. You have to be aware of whether it's a native PDF, I call that a text PDF, or a scanned or image PDF. And what it does with native PDFs is it looks for text elements. Again, those are like code that indicates this is text. And you can deal with raster images, that's pixel images, or vector, which draws the lines, and that's what makes them infinitely scalable in many situations. And then in PDFs, you can deal with tabular data, but you probably have to use a specialized program like Scraper, Wiki, or Tabula in order to get that. And then finally, media like images and video and audio. Getting images is easy. You can download them in a lot of different ways. And then if you want to read data from them, say for instance, you have a heat map of a country, you can go through it, but you'll probably have to write a program that loops through the image pixel by pixel to read the data and then encode it numerically into your statistical program. Now that's my very brief summary, and let's summarize that. First off, if the data you're trying to get at doesn't have an existing API, you can try scraping. And you can use specialized apps for scraping, or you can write code in a language like R or Python. But no matter what you do, be sensitive to issues of copyright and privacy so you don't get yourself in hot water, but instead you make an analysis that can be of great use to you or to your client. The next step in data sourcing is making data. And specifically, we're talking about getting new data. I like to think of this as you're getting your hands on and you're getting data de novo, new data. So, can't find the data that you need for your analysis? Well, one simple solution is do it yourself. And we're going to talk about a few general strategies used for doing that. Now, these strategies vary on a few dimensions. First off is the role. Are you passive and simply observing stuff that's happening already? Or are you active where you play a role in creating the situation to get the data? And then there's the QQ question, and that is, are you going to get quantitative or numerical data? Or are you going to get qualitative data, which usually means text, paragraphs, sentences, as well as things like photos and videos and audio? And also, how are you going to get the data? Do you want to get it online or do you want to get it in person? Now, there's other choices than these, but these are some of the big delineators of the different methods. When you look at those, you get a few possible options. Number one is interviews, and I'll say more about those. Another one is surveys. A third one is card sorting. And a fourth one is experiments, although I actually want to split experiments into two kinds of categories. The first one is laboratory experiments, and that's in-person projects where you shape the information or an experience for the participants as a way of seeing how that involvement changes their reactions. It doesn't necessarily mean that you're a participant, but you create the situation. And then there's also A/B testing. This is automated online testing of 2 or more variations on a web page. It's a very, very simple kind of experimentation that's actually very useful for optimizing websites. So, in sum, from this very short introduction, make sure you can get exactly what you need. Get the data you need to answer your question. And if you can't find it somewhere, then make it. And as always, you have many possible methods, each of which have their own strengths and their own compromises. And we'll talk about each of those in the following sections. The first method of data sourcing where you're making new data that I want to talk about is interviews. And that's not because it's the most common, but because it's the one you would do for the most basic problem. Now, basically, an interview is nothing more than a conversation with another person or a group of people. And the fundamental question is, why do interviews as opposed to doing a survey or something else? Well, there's a few good reasons to do that. Number one, you're working with a new topic and you don't know what people's responses will be or how they'll react. And so you need something very open-ended. Number two, you're working with a new audience. You don't know how they will react in particular to what it is you're trying to do. And number three, something's going on with the current situation. It's not working anymore, and you need to find what's going on and you need to find ways to improve. The open-ended information where you get past your existing categories and boundaries can be one of the most useful methods for getting that data. If you want to put it another way, you want to do interviews when you don't want to constrain responses. Now, when it comes to interviews, you have one very basic choice, and that's whether you do a structured interview. And with a structured interview, you have a predetermined set of questions, and everyone gets the same questions in the same order. It gives a lot of consistency, even though the responses are open-ended. And then you can also have what's called an unstructured interview. And this is a whole lot more like a conversation where you as the interviewer and the person you're talking to, your questions arise in response to their answers. Consequently, an unstructured interview can be different for each person that you talk to. Also, interviews are usually done in person, but not surprisingly, they can be done over the phone or often online. Now, a couple of things to keep in mind about interviews. Number one is time. Interviews can range from just a few minutes to several hours per person. Second is training. Interviewing is a special skill that usually requires specific training. Now, asking the questions is not necessarily the hard part. The really tricky part is the analysis. The hardest part of interviews by far is analyzing the answers for themes and way of extracting the new categories and the dimensions that you need for your further research. The beautiful thing about interviews is they allow you to learn things that you never expected. So, in sum, interviews are best for new situations or new audiences. On the other hand, they can be time-consuming, and they also require special training both to conduct the interview, but even more to analyze the highly qualitative data that you get from them. The next logical step in data sourcing and making data is surveys. Now, think of this. If you want to know something, just ask. That's the easy way. And you want to do a survey under certain situations. The real question is, do you know your topic and your audience well enough to anticipate their answers, to know what the range of their answers and the dimensions and the categories that are going to be important? If you do, then a survey might be a good approach. Now, just as there were a few dimensions for interviews, there's a few dimensions for surveys. You can do what's called a closed-ended survey. That's also called a forced choice. It's where you give people just particular options like a multiple choice. You can have an open-ended survey where you have the same questions for everybody, but you allow them to write in a free-form response. You can do surveys in person, and you can also do them online or over the mail or phone or however. And now it's very common to use software when doing surveys. Some really common applications for online surveys are SurveyMonkey and Qualtrics, or at the very simple end, there's Google Forms, and at the simple and pretty end, there's Typeform. There's a lot more choices, but these are some of the major players in how you can get data from online participants in survey format. Now, the nice thing about surveys is, they're really easy to do. They're very easy to set up, and they're really easy to send out to large groups of people. You can get tons of data really fast. On the other hand, the same way that they're easy to do, they're also really easy to do badly. The problem is that the questions you ask, they can be ambiguous, they can be double-barreled, they can be loaded, and the response scales can be confusing. So if you say, I never think this particular way, and a person puts strongly disagree, they may not know exactly what you're trying to get at. So you have to take special effort to make sure that the meaning is clear, unambiguous, and that the rating scale, the way that people respond, is very clear and they know where their answer falls. Which gets us into one of the things about people behaving badly, and that is beware the push-pull. Now, especially during election time, like we're in right now, a push-pull is something that sounds like a survey, but really what it is a very biased attempt to get data, just fodder for social media campaigns, or I'm going to make a chart that says that 98% of people agree with me. A push-pull is one that's so biased, there's really only one way to answer to the questions. This is considered extremely irresponsible and unethical from a research point of view. Just hang up on them. Now, aside from that egregious violation of research ethics, you do need to do other things like watch out for bias in the question wording, in the response options, and also in the sample selection, because any one of those can push your responses off one way or another without you really being aware that it's happening. So in sum, let's say this about surveys. You can get lots of data quickly. On the other hand, it requires familiarity with the possible answers in your audience, so you know sort of what to expect. And no matter what you do, you need to watch for bias to make sure that your answers are going to be representative of the group that you're really concerned about understanding. An interesting topic in data sourcing when you're making data is card sorting. Now, this isn't something that comes up very often in academic research, but in web research, this can be a really important method. Think of it as what you're trying to do is like building a model of a molecule here. You're trying to build a mental model or a model of people's mental structures. Put more specifically, how do people organize information intuitively? And also, how does that relate to the things that you're doing online? Now, the basic procedure goes like this. You take a bunch of little topics and you write each one on a separate card. And you can do this physically with like 3x5 cards, or there's a lot of programs that allow you to do a digital version of it. Then what you do is you give this information to a group of respondents and the people sort those cards. So they put similar topics with each other, different topics over here, and so on. And then you take that information, and from that, you're able to calculate what's called dissimilarity data. Think of it as like the distance or the difference between various topics. And that gives you the raw data to analyze how things are structured. Now, there are two very general kinds of card sorting tasks. There are generative and there's evaluative. A generative card sorting task is one in which respondents create their own sets, their own piles of cards using any number of groupings they like. And this might be used, for instance, to design a website. If people are going to be looking for one kind of information next to another one, then you want to put that together on the website so they know where to expect it. On the other hand, if you've already created a website, then you can do an evaluative card sorting. This is where you have a fixed number or fixed names of categories, like for instance, the way you've set up your menus already. And then what you do is you see if people naturally put the cards into these various categories that you've created. That's a way of verifying that your hierarchical structure makes sense to people. Now, whichever method you do, generative or evaluative, what you end up with when you do a card structure is an interesting kind of visualization. It's called a dendrogram. That actually means branches. And what we have here is actually 150 data points. If you're familiar with Fisher's iris data, that's what's going on here. And it groups it from one giant group on the left and then splits it in pieces and pieces and pieces until you end up with lots of different individual level observations at the end. But you can cut things off into 2 or 3 groups or wherever it's most useful for you here as a way of visualizing the entire collection of similarity or dissimilarity between the individual pieces of information that you had people sort. Now, I'll just mention very quickly, if you want to do digital card sorting, which makes your life infinitely easier because keeping track of physical cards is really hard, you can use something like Optimal Workshop or User Zoom or UX Suite. These are some of the most common choices. Now, let's just sum up what we've learned about card sorting in this extremely brief overview. Number one, card sorting allows you to see intuitive organization of information in a hierarchical format. You can do it with physical cards, or you also have digital choices for doing the same thing. And when you're done, you actually get this hierarchical or branched visualization of how the information is structured and related to each other. When you're doing your data sourcing and you're making data, sometimes you can't get what you want through the easy ways, and you got to take the hard way. And you can do what I'm calling laboratory experiments. Now, of course, when I mention laboratory experiments, people start to think of stuff like, Dr. Frankenstein in his lab, but lab experiments are less like this. And in fact, they're a little more like this. Nearly every experiment I have done in my career has been a paper and pencil one with people in a well-lighted room, and it's not been the threatening kind. Now, the reason you do a lab experiment is because you want to determine cause and effect. And this is the single most theoretically viable way of getting that information. Now, what makes an experiment is the fact that researchers play active roles in experiments with manipulations. Now, people get a little freaked out when they hear manipulations, think that you're coercing people and messing with their mind. All that means is you are manipulating the situation. You're causing something to be different for one group of people or one situation than another. It's a benign thing, but it allows you to see how people react to those different variations. Now, you're going to want to do an experiment. You're going to want to have focused research. It's usually done to test one thing or one variation at a time. And it's usually hypothesis driven. Usually you don't do an experiment until you've done enough background research to say, I expect people to react this way to this situation and this way to the other. A key component of all of this is that experiments almost always have random assignments. So regardless of how you got your sample, when they're in your study, you randomly assign them to one condition or another. And what that does is it balances out the pre-existing differences between groups. And that's a great way of taking care of confounds and artifacts, the things that are unintentionally associated with differences between groups that provide alternate explanations for your data. If you've done good random assignment and you have a large enough people, then those confounds and artifacts are basically minimized. Now, some places where you're likely to see laboratory experiments in this version are, for instance, eye tracking and web design. That's where you have to bring people in front of a computer and you stick a thing there that sees where they're looking. That's how we know, for instance, that people don't really look at ads on the side of web pages. Another very common place is research in medicine and education, and in my field, psychology. And in all of these, what you find is that experimental research is considered the gold standard for reliable, valid information about cause and effect. On the other hand, while it's a wonderful thing to have, it does come at a cost. Here's how that works. Number one, experimentation requires extensive specialized training. It's not a simple thing to pick up. Two, experiments are often very time consuming and labor intensive. I've known some that take hours per person. And number three, experiments can be very expensive. So what that all means is you want to make sure that you've done enough background research, and you need to have a situation where it's sufficiently important to get really reliable cause and effect information to justify these costs for experimentation. In sum, laboratory experimentation is generally considered the best method for causality or assessing causality. That's because it allows you to control for confounds through randomization. On the other hand, it can be difficult to do, so be careful and thoughtful when considering whether you need to do an experiment and how to actually go about doing it. There's one final procedure I want to talk about in terms of data sourcing and making new data. It's a form of experimentation, and it's simply called A/B testing, and it's extremely common in the web world. So for instance, I just barely grabbed a screenshot of Amazon.com's homepage, and you've got these various elements on the homepage. And I just noticed, by the way, when I did this, that this woman is actually a animated GIF. So she moves around. That was kind of weird. Never seen that before. But the thing about this entire layout, how things are organized and how they're on there, will have been determined by variations on A/B testing by Amazon. Here's how it works. For your web page, you pick one element like what's the headline or what are the colors or what's the organization or how do you word something. And you create multiple versions, maybe just two, version A and version B, which is why you called A/B testing. And then when people visit your web page, you randomly assign those visitors to one version or another. You have software that does that for you automatically. And then you compare the response rates on some response. I'll show you those in a second. And then once you have enough data, you implement the best version. You sort of set that one solid, and then you go on to something else. Now, in terms of response rates, there's a lot of different outcomes you can look at. You can look at how long a person's on a page. You can actually do mouse tracking if you want to. You can look at click-throughs. You can also look at shopping cart value or abandonment. A lot of possible outcomes. All of these contribute through A/B testing to the general concept of website optimization to make your website as effective as it can possibly be. Now, the idea also is that this is something you're going to do a lot. You can perform A/B tests continually. In fact, I've seen one person say that what A/B testing really stands for is always be testing. Kind of cute, but it does give you the idea that improvement is a constant process. Now, if you want some software to do A/B testing, two of the most common choices are Optimizely and VWO, which stands for Visual Web Optimizer. Now, many others are available, but these are especially common. And when you get the data, you're going to use statistical hypothesis testing to compare the differences, or really, the software does it for you automatically, but you may want to adjust the parameters because most software packages cut off testing a little too soon and the information is not quite as reliable as it should be. But in sum, here's what we can say about A/B testing. It's a version of website experimentation. It's done online, which makes it really easy to get a lot of data very quickly. It allows you to optimize the design of your website for whatever outcome is important to you. And it can be done as a series of continual assessments, testing, and development to make sure that you're accomplishing what you want to as effectively as possible for as many people as possible. The very last thing I want to talk about in terms of data sourcing is to talk about the next steps. And probably the most important thing is, don't just sit there. I want you to go and see what you already have. Try to explore some open data sources. And if it helps, check with a few data vendors. And if those don't give you what you need to do your project, then consider making new data. Again, the idea here is get what you need and get going. Thanks for joining me and good luck on your own projects.